Welcome to the Deep Dive. Today, we're jumping into a topic that's, well, it's everywhere, artificial intelligence. It's exciting, a bit mysterious maybe, often sounds like pure science fiction. But our mission today, it's to cut through that noise. We want to give you a clear picture, help you separate the real breakthroughs from the hype. We'll look at where AI came from, its journey, where we are right now, and really importantly, what it might mean for you. We've gathered some fantastic sources, essentially an expert guide to AI's past, present, and future. Lots of fascinating stuff in there.
Absolutely. We're aiming to give you a solid framework for thinking about AI. We'll touch on some maybe surprising historical moments and then really dig into how it's affecting, well, pretty much everything: daily life, society, the works, the good and the challenging parts too.
Okay, so let's kick things off with the basics. We hear AI constantly, but what is it, really? Beyond, thinking robots in movies, fundamentally, our sources define it as computer systems doing tasks that used to need human smarts.
Like learning or reasoning.
Exactly. Problem solving, perception, making decisions, even creativity.
Right. And a really key point here is that AI isn't one single thing. It's more like an umbrella term for a whole bunch of technologies. So the popular image is often these super general conscious machines, but today's reality is mostly specialized AI. Think about it, the AI that beat the world champion at Go. That's incredibly smart at Go.
But it can't, say, diagnose disease.
Precisely. Or predict protein structures for vaccines. Those are different, highly specialized systems, deep intelligence, but narrow.
That's a helpful distinction. And speaking of distinctions, this next bit is where I think a lot of people get tangled up the terms AI, machine learning, and deep learning. They get thrown around almost interchangeable.
Well, definitely. It causes a lot of confusion.
There's a good analogy, right? Like nested circles.
Exactly, like Russian dolls. AI is the biggest doll, the overall concept. Machine learning, or ML, is a smaller doll inside AI. And then deep learning, DL, is an even smaller one, tucked inside ML.
Okay, let's unpack that. AI first, the big circle.
So AI covers any technique that mimics human intelligence. That includes older approaches too, like symbolic AI, think rule-based systems.
Like those old expert systems.
Yes. From the 80s, programmed with lots of if-then rules for specific tasks, maybe a medical diagnosis or something, even classic search algorithms in chess programs, or your GPS finding a route that's all under the broad AI umbrella, based on logic, not necessarily learning from data piles.
Got it. So machine learning, the middle circle.
That's where the system starts to learn patterns directly from data. Instead of just following pre-programmed rules for every single possibility, you train ML algorithms on data sets.
And they get better with more data.
They do. More experience, better performance. This is how most modern AI actually works, learning from data.
Which brings us to deep learning, the core.
Right, the NG behind the really big recent breakthroughs. Deep learning uses these multi-layered artificial neural networks, ANNs. They're inspired by how our brains are structured.
You're inspired by, not copies of.
Exactly. The key difference from traditional ML is that DL models can automatically figure out the important features and complex patterns from raw data, like pixels in an image or words in text. Traditional ML often needed humans to kind of point out the important bits first. Feature engineering, they call it.
So DL doesn't need that hand-holding.
Pretty much. It learns hierarchies of features on its own. That makes it incredibly powerful for messy, unstructured stuff like images, audio, natural language. It's what powers your voice assistant and all this new generative AI we're seeing.
It really does feel like things have exploded recently, but why now? What changed? You mentioned this perfect storm idea.
Yes, it wasn't just one thing. For a long time, we had some of the ideas, the algorithms, but not everything else needed. It really took three key forces coming together.
Okay, what are they?
Pillar one, big data, just the sheer amount of digital information, text, images, everything generated by the internet. That's the raw material, the textbooks for AI.
Makes sense. Pillar two.
Sophisticated algorithms, especially the deep learning algorithms we just talked about. These gave us the methods to actually learn from all that data effectively.
And a third piece.
Massive computational power, specifically GPUs, graphics processing units. They were first made for video games, complex graphics.
Right, for making games look realistic.
Exactly. But it turns out their architecture, doing lots of calculations at once in parallel, is perfect for training deep neural networks. The crucial insight is you needed all three. Take away the data or the algorithms or the computing power, and this modern AI revolution just wouldn't have happened.
So let's zoom in on that learning part. It sounds almost magical, but it's grounded in math and computation. The analogy of an AI system as a student is helpful here.
It is. It helps demystify it a bit. So in this analogy, the data is the textbook, or maybe the whole library. If you want an AI to learn cat recognition, you feed it millions of cat pictures. That's its study material. The algorithm is the student's learning method, how they study. It's the set of mathematical rules the system uses to analyze the data, find patterns, correlations like noticing certain pixel arrangements often mean cat.
And the model?
The model is the knowledge the student gains after studying. It's the train system, the complex mathematical structure that represents all the patterns it learned. This model can then look at a new picture, one it's never seen, and say, yep, that's a cat.
And deep learning uses those artificial neural networks for this.
Right. These networks have layers, inspired by the brain, processing information progressively. And they learn through a process called backpropagation. Essentially, the network makes a prediction, checks how wrong it was, and then adjusts its internal connections, weights bit by bit, to reduce that error next time. It's like constantly tuning an incredibly complex instrument until it plays accurately.
Okay, so that's the learning process. But just like people learn differently, AI probably needs different training methods depending on the task.
Absolutely. There are three main approaches. The most common is supervised learning. Here, you give the AI data that's already labeled.
Like this email is spam, this one isn't.
Precisely. Thousands of examples already tagged with the right answer. The AI learns the mapping from input email content to output, spam, not spam.
Okay, makes sense. What else?
Then you have unsupervised learning. Here, you give the AI unlabeled data. No answers provided. It has to find hidden structures or patterns or clusters all on its own.
Can you give an example?
There was a really famous Google experiment back in 2012. They showed a neural network millions of unlabeled video thumbnails from YouTube, and the network, completely on its own, learned to recognize the concept of a cat. Nobody ever told it, this is a cat. It just figured out that pattern from the raw pixels.
Yeah.
Quite amazing, really.
Wow. Okay, so supervised, unsupervised, what's the third?
Reinforcement learning. This is more like training a pet through trial and error. You have an AI agent acting in an environment. It gets positive rewards for action that lead to a good outcome and penalties for bad ones.
So it learns by doing.
Exactly. Over time, it figures out a strategy, a policy to maximize its total reward. This is super powerful for mastering complex games like chess or Go, where the consequences of actions aren't immediately obvious, and it's absolutely crucial for robotics, teaching robots how to interact with the physical world.
So we've kind of defined AI, looked under the hood a bit, but how did we even get to this point? It feels so sudden, but the dream is much older, isn't it?
Oh, much older. The roots go way back. Philosophically, you can find ideas related to artificial minds even in the 17th century with Descartes. And get this, Jonathan Swift's Gulliver's Travels in 1726 described a fictional machine, the engine, that could generate text by combining words mechanically.
That sounds eerily like modern generative AI.
Doesn't it? Uncanny. Then literature played a huge role. Carol Opek's play RUR from 1921 gave us the word robot, and Isaac Asimov's I, Robot in 1950, with his 3 laws of robotics, was already grappling with the ethics of intelligent machines.
But it wasn't just fiction, right? There were early machines.
Definitely. Back in 1914, Leonardo Torres y Quevedo built El Ajedrecista, an actual electromechanical machine that could play a simple chess endgame. A huge theoretical step came in 1943 with McCulloch and Pitts. They published the first mathematical model of a neuron, foundational stuff for neural networks.
And then came Turing.
Alan Turing, yes. His 1950 paper, Computing Machinery and Intelligence, was monumental. He asked the big question, can machines think? And he proposed the Turing test as a way to measure machine intelligence.
Which then led to AI becoming a real field of study.
Exactly. The official christening moment was the Dartmouth Summer Research Project in 1956. That's where John McCarthy actually coined the term artificial intelligence.
And things started moving quickly after that.
Pretty quickly. You had Frank Rosenblatt's perceptron in 57, an early neural net. McCarthy developed the LISP programming language in 58, which became dominant in AI research for ages. And in 59, Arthur Samuel at IBM coined machine learning for his checkers program that actually learned to improve its game.
Were there any actual AIs people could interact with back then?
Yep.
There were. Joseph Weissenbaum's ELIZA chatbot in 1966 simulated a psychotherapist. It was simple pattern matching, really, but people reacted incredibly strongly to it, attributing real understanding.
Fascinating. Shows the psychological power early on.
It does. And then Stanford built Shaky the robot between 66 and 72. Shaky was the first mobile robot that could perceive its environment, reason about its actions, and navigate. a huge milestone in integrating perception, reasoning, and action.
Now, you mentioned AI's history isn't just a straight line up. There were these AI winters. What were those about?
Right, it's crucial to understand it's been cyclical. Hype, followed by disappointment, funding cuts. The first AI winter really hit in the mid-1970s.
Why? What went wrong?
Well, the early, very optimistic predictions just didn't pan out. Progress slowed. Then, a 1969 book by Minsky and Papert called Perceptrons pointed out some fundamental limitations of the simple neural networks they had back then. That really put a damper on things. Plus, critical reports like the Lighthill Report in the UK led governments to slash AI research funding.
But it didn't die out completely.
No, it came back in the 1980s, largely thanks to the commercial success of expert systems. These were rule-based AIs capturing human expertise. DEC's XCon system, which configured computer orders, saved them millions. It showed AI could actually deliver business value.
And there was a research breakthrough, too.
A massive one. The backpropagation algorithm, which allows efficient training of multi-layered neural networks, was rediscovered and popularized around 1986 by Geoffrey Hinton and others. That reignited serious neural network research.
But then, another winter.
Yes, the second AI winter hit in the late 80s. Those expert systems turned out to be really expensive to build and maintain, and quite brittle. They broke easily if conditions changed slightly. The market for them kind of collapsed.
So the 90s and 2000s were quieter.
Quieter, but important groundwork was laid. IBM's Deep Blue beat Kasparov at chess in '97. Okay, it was mainly massive computing power, but still a huge public moment. Crucially, the World Wide Web was taking off, creating the enormous data sets that would fuel the next wave. And techniques like support vector machines, SVMs, and LSTM networks were developed then, too.
Which sets the stage for the current era, the big explosion driven by that data, algorithms, and compute power combo.
Exactly. Things really accelerated from the late 2000s. Fei-Fei Li started the ImageNet project around 2007, a huge database of labeled images. This became the standard testbed for computer vision.
And that led to AlexNet.
Yes, in 2012, Geoffrey Hinton's team used a deep convolutional neural network called AlexNet on ImageNet and just blew away the competition. Their error rate was dramatically lower than anything before. That moment really kicked off the deep learning frenzy we're still in.
Then came AlphaGo.
AlphaGo in 2016. Google DeepMind's program beating Lee Sedol, the Go world champion. Go is incredibly complex, relies on intuition. Beating a top human showed deep learning plus reinforcement learning could tackle immense strategic depth.
And a transformer architecture.
2017, Google's paper Attention is All You Need introduced the transformer, which is the basis for almost all the big language models today, GPT, Gemini, Claude. Its attention mechanism lets it handle long-range context in language much better than previous models. That's key.
Which led directly to things like ChatGPT.
Pretty much. OpenAI released GPT-3 in 2020, showing incredible text generation ability. Then ChatGPT landed in late 2022 and just brought this powerful generative AI to everyone's fingertips. That really sparked the intense public focus we see now. And it keeps moving fast. We saw Sora for video and Gemini 1.5 with huge context windows just this year in 2024.
Okay, so AI isn't one thing. And our sources talk about different types of AI based on how general their abilities are. Can you break that down?
Sure. There are basically three categories people talk about. First, and this is crucial, is artificial narrow intelligence, or ANI, sometimes called weak AI.
And this is what we have now.
This is the only kind of AI we have successfully built so far. Every AI you use today, Siri, Google Search, AlphaGo, facial recognition, Netflix recommendations, even self-driving car systems, is an ANI. They can be brilliant, superhuman even, at one specific task.
But only that task.
Exactly. AlphaGo can't play tic-tac-toe or make you coffee. Its intelligence is narrow.
Okay. What's the next level?
That's artificial general intelligence, or AGI, strong AI. This is the hypothetical future AI that would have human-like cognitive abilities across a wide range of tasks. It could reason, learn abstract concepts, understand context, transfer knowledge like we do.
The kind of AI in sci-fi, basically.
Pretty much. It's a long-term ambition for labs like OpenAI and Google DeepMind. But despite the recent buzz, most experts think true AGI is still decades away, maybe longer. It's a huge leap from ANI.
And the third type?
Purely theoretical at this point. Artificial Superintelligence, or ASI. This would be an AI that vastly surpasses human intelligence in essentially every domain.
Smarter than us at everything.
Everything. Science, creativity, social skills. A key idea linked to ASI is recursive self-improvement, an AI smart enough to make itself even smarter, potentially leading to an uncontrollable intelligence explosion. This is where you get both the utopian hopes of solving all world problems and the deep existential fears.
It's interesting, though, because even though today's best AI is still technically narrow ANI, the rise of generative AI feels like it's changed the game, changed how people perceive AI.
Absolutely. Generative AI has had a massive impact on public perception.
How is it defined exactly? What makes it generative?
It's defined by its ability to create new original content that could be text, images, music, code. It's not just analyzing existing data or classifying it like older AI. It's generating something novel.
Which feels much closer to human creativity.
It does, and that's the psychological impact. Tools like ChatGPT, even though there are still ANIs under the hood, they can converse, write poetry, generate images. They give the impression of broader intelligence. For many people, it feels like they're passing a kind of cultural Turing test.
Making AGI feel closer than maybe it is.
Exactly. It's made the abstract idea of AGI feel much more tangible, more immediate, fueling both excitement and anxiety.
So how do these things actually work? How does ChatGPT write an essay or Midjourney create an image?
It's generally a multi-phase process built on deep learning. Phase 1 is training the foundation model. This involves taking a massive deep learning model, like a large language model, an LLM for text, and training it on just enormous amounts of raw data, often huge chunks of the internet.
Sounds expensive.
Incredibly. Thousands of specialized computer chips, GPUs running for weeks or months, millions of dollars in compute costs. The result is this giant neural network, sometimes with trillions of connections, that's learned statistical patterns from all that data.
Okay, so that's the raw model. What's next?
Phase 2 is tuning and alignment. The raw model might know language patterns, but it doesn't know how to be helpful or safe. So it's fine-tuned on smaller, higher quality data sets. A really important part here, especially for chatbots, is reinforcement learning from human feedback, RLHF.
How does that work?
Humans actually look at different responses the model gives to prompts and rank them, which one is better, more helpful, less harmful. This feedback is used to further train the model, essentially rewarding it for behaving in ways humans prefer. It helps align the AI with desired values.
And the final step is using it.
Phase 3, generation or inference. Now, the tuned model takes your prompt, your instruction or question, and uses its learned patterns to predict the most likely sequence of words, or pixels for images, to come next. It builds the response piece by piece. There's often a bit of controlled randomness added too.
Is that why you can get slightly different answers sometimes?
Yes, exactly. It allows for more varied and creative outputs, not just the single most probable response every time.
What are the key technologies making this possible? We mentioned transformers already.
Transformers are huge, yes. That 2017 architecture powers almost all the big language models. Its attention mechanism is key for understanding context. For images, two other architectures were really important. Generative adversarial networks, or GANs.
Adversarial. Sounds like a fight.
Kind of. You have two neural networks, a generator trying to create realistic fakes, like images of faces, and a discriminator trying to spot the fakes. They compete, pushing the generator to get better and better. GANs were behind a lot of the early realistic AI image generation.
And the other one?
Diffusion models. These are behind the current state-of-the-art text-to-image models like DALL-E 3 or Stable Diffusion. They work differently, they learn to take random noise like TV static and gradually refine it step by step into a coherent image that matches the text prompt.
And the big names driving this: OpenAI, Google.
Definitely. OpenAI, Google with DeepMind, Anthropic, Meta. Those are some of the major players pushing the boundaries right now.
Okay, we've got the concepts, the history, the types. Let's talk about where AI actually shows up. It's often hidden in plain sight in our everyday lives, right?
Oh, absolutely. It's seamlessly woven into so much of what we do. Think about digital assistants like Siri or Alexa. They use natural language processing to understand you, machine learning to get better at recognizing your voice. Your smart home devices often rely on AI.
Search engines, too.
Massively. Google search isn't just keyword matching anymore. It uses sophisticated AI to understand the intent and context behind your query, giving you relevant results, autocomplete suggestions. The people also ask box.
Navigation apps.
Yep. Google Maps, Waze, Uber, Lyft. They use AI constantly, analyzing real-time, anonymized traffic data from users to predict congestion, optimize routes, calculate ETAs, even set dynamic pricing for rides.
And social media feeds. Streaming recommendations.
All driven by AI recommendation engines. TikTok, Instagram, Netflix, Spotify, they track what you watch, listen to, interact with, and use AI to build personalized feeds designed to keep you engaged. Even things like spam filters in your email or the autocorrect on your phone are some of the oldest, most mature uses of AI, constantly learning.
Moving beyond the everyday, healthcare seems like a huge area for AI impact, potentially life-saving stuff.
It really is. One major area is medical imaging. Deep learning, specifically computer vision, is getting incredibly good at analyzing X-rays, CT scans, MRIs.
Finding things humans might miss.
Exactly. Detecting subtle signs of diseases like cancerous tumors, diabetic retinopathy, or indicators of stroke, sometimes earlier or more accurately than human radiologists. There was a study with Mass General and MIT where an AI hit 94% accuracy finding lung nodules versus 65% for humans reading the same scans. Think of it as a powerful second opinion.
Wow. What else in healthcare?
Personalized medicine. AI can analyze a patient's electronic health records, genetic data, lifestyle factors all together to predict how they might respond to different treatments, helping tailor things like chemotherapy regimens. Mayo Clinic and IBM Watson have worked on this, also drug discovery. AI is speeding up the incredibly long and expensive process of finding new drugs. DeepMind's AlphaFold 2 predicting protein structures is a huge deal here. Understanding proteins is key to understanding diseases and designing drugs.
Is it helping with the paperwork side too? Healthcare has so much admin.
Yes, administrative automation is another big one. Automating record keeping, transcribing doctor's notes, processing insurance claims, even optimizing patient flow in hospitals to reduce wait times. Geisinger Health and Valley Medical Center have used AI to improve efficiency, freeing up nurses for patient care. And AI is used for predictive health, identifying patients at high risk for things like sepsis or hospital readmission, so interventions can happen earlier.
Okay, let's switch to finance. Lots of data there. Seems ripe for AI.
Absolutely. Finance was an early adopter. Algorithmic trading is huge AI systems making high-frequency trades in microseconds based on real-time market data. Goldman Sachs is big in this space. Fraud detection is maybe even more widespread and critical.
Catching dodgy transactions.
Exactly. Machine learning models monitor billions of transactions, looking for anomalies, patterns that deviate from normal behavior, flagging potential fraud instantly. JP Morgan Chase, Barclays, all major banks rely heavily on this.
What about getting loans?
Credit scoring and loan processing are being transformed. Instead of just looking at old credit reports, AI can analyze a much wider range of data, maybe utility payments, rental history, even some online behavior for a more holistic view of credit worthiness. Companies like Upstart claim their AI models approve more loans with lower default rates than traditional methods.
And customer service.
Personalized banking through AI chatbots is common now, like Bank of America's Erica. And robo-advisors use AI to provide automated, low-cost investment management and financial planning, making it accessible to more people.
Hitting the road transportation. Autonomous vehicles get all the headlines, but AI's impact is broader, isn't it?
It is. Autonomous vehicles, yes, that's the most visible part. Tesla's autopilot, Waymo's driverless taxis, they rely on a whole suite of AI computer vision to see pedestrians and signs, sensor fusion, combining data from cameras, radar, LiDAR, and reinforcement learning for driving decisions. Full self-driving is still a challenge, but advanced driver assistance is here now.
What about managing traffic itself?
Intelligent traffic management in smart cities. AI analyzes real-time data from sensors and cameras to dynamically adjust traffic light timings, reroute traffic, reduce congestion. Systems in cities like Los Angeles have shown they can cut travel times.
And for deliveries, logistics.
Huge impact there. Logistics and route optimization for companies like UPS, FedEx, Amazon. AI tackles the incredibly complex traveling salesman problem, finding the most efficient routes considering traffic, weather, delivery windows, fuel costs,
Right.
saving billions and cutting emissions. And predictive maintenance uses sensors and AI to predict when vehicle parts might fail, allowing maintenance before a breakdown happens.
Finally, entertainment. AI seems to be really shaking things up there, creatively and industrially.
It's a fascinating and sometimes contentious area. We're seeing AI used in content generation and visual effects, VFX, generating music, drafting scripts, creating amazing digital environments or special effects. It can automate time-consuming tasks like rotoscoping or color grading.
Makes sense for efficiency. What about how we consume content?
Personalization and recommendation is key. Netflix, YouTube, Spotify. Their recommendation engines are pure AI, analyzing your viewing or listening habits to curate feeds and suggest new content to keep you hooked. In gaming, AI is used to create smarter non-player characters, NPCs, generate game worlds procedurally, and even adapt the difficulty dynamically.
But this has caused some conflict, hasn't it? The Hollywood strikes.
Yes, the 2023 writers and actors strikes were significantly fueled by concerns about AI, worries about using AI to write scripts or create digital replicas of actors without proper consent or compensation. The final agreements included new rules around AI use, requiring consent and payment for these digital replicas.
So there's a tension there.
Definitely. It also reflects broader societal feelings. Surveys show people often prefer human creativity, especially for things like music or dialogue, and a majority, something like 67%, think AI-generated content should be clearly labeled. It points to AI's dual role. Great for automating grunt work, but in creative fields may be best seen as an augmentation tool, a co-pilot for human creativity rather than a replacement.
So putting it all together, AI offers incredible potential benefits, but there are clearly significant risks and downsides too, a real balancing act for society.
It really is. Let's look at the future of work. There's genuine concern about job displacement. Routine, repetitive tasks, both manual and cognitive, are vulnerable to automation by AI.
We hear about factory jobs, but white collar too.
Yes. That Goldman Sachs report estimated generative AI could impact 300 million full-time jobs globally. Think entry-level roles in areas like finance, paralegal work, content summarization, tasks that involve processing information according to rules.
But does it also create jobs?
History suggests technological shifts do create new roles. We're seeing demand for new collar jobs directly related to AI specialists, prompt engineers, people who audit AI systems for bias. Perhaps more importantly, AI is often used for augmentation.
Making humans more productive.
Exactly. That MIT-Stanford study on customer service agents showed a 14% productivity boost with an AI assistant. It can handle the routine parts, freeing up humans for tasks requiring judgment, empathy, creativity, strategy. But this transition requires a huge focus on education, reskilling, and rethinking work.
Another major concern you touched on is algorithmic bias. AI reflecting our own societal biases back at us, sometimes amplified.
It's a critical issue. AI systems learn from data, and if that data reflects historical biases, gender, race, socioeconomic status, the AI will learn those biases too. We saw it with Amazon's biased recruiting tool, the Compass algorithm in criminal justice, showing racial disparities, biased loan applications, even healthcare algorithms inadvertently discriminating because they used biased proxies like healthcare spending.
How do we fix that?
It's tough. Mitigation strategies include using more diverse and representative training data, conducting regular audits specifically looking for bias, demanding more transparency and explainability from AI systems, and building fairness metrics directly into the development process. But it's an ongoing challenge.
And then there's privacy. AI runs on data, often our data.
A massive challenge. First, there's the issue of mass data collection and surveillance facial recognition everywhere. Constant online tracking. It raises questions about autonomy and control. Second is the power of inference. AI can deduce sensitive things about you, your health, political views, sexual orientation, from seemingly unrelated data points you share online, often without you realizing or consenting.
And deepfakes.
Deepfakes are a growing problem. These hyper-realistic fake videos, images, or audio generated by AI can be used for fraud, creating non-consensual pornography, spreading political misinformation. It really erodes trust in what we see and hear online. And our laws, like GDPR or CCPA, are struggling to keep pace with how AI uses data, especially concepts like the right to be forgotten when data is baked into a trained model.
With all these risks, bias, job impacts, privacy, there's a clear need for rules for AI governance.
Absolutely. There's a global push for it. Effective AI governance needs to be built on principles like fairness, transparency, getting inside the black box, accountability, who's responsible when AI messes up, safety and security, and privacy.
Are we seeing actual regulations emerge?
We are. The European Union passed its Comprehensive AI Act in 2024. It takes a risk-based approach, stricter rules for high-risk AI applications like in healthcare or critical infrastructure. In the U.S., NIST, the National Institute of Standards and Technology, has developed an AI risk management framework, though it's currently voluntary guidelines.
Is there a danger of regulating too much, stifling innovation?
That's the governance paradox. You need rules to prevent harm, ensure fairness, protect rights. But if regulations are too rigid or slow-moving, they could hamper beneficial AI development in areas like medicine or climate science, or potentially disadvantage countries economically compared to those with looser rules. Finding that right balance is the key challenge policymakers are wrestling with globally. And ethical guidelines need to extend beyond just laws. That RCIV hidden prompts incident you mentioned earlier is a stark example. Researchers trying to trick AI peer reviewers. It shows how competitive pressures can lead to ethical lapses, even in academia, highlighting the need for clear professional norms around AI use.
So looking ahead, what are the big research trends shaping the next wave of AI?
One major area is multimodal AI, moving beyond systems that only understand text or only images to AI that can process and reason across multiple modalities, text, images, audio, video simultaneously, like humans do. OpenAI's Sora video generator is a step in this direction. It's seen as key for more human-like understanding.
What about AI getting smarter, reasoning better?
That's a huge focus. Advanced AI reasoning. Current AI is great at pattern matching, but researchers are working hard to give it stronger capabilities for logical deduction, understanding cause and effect, planning, and solving complex problems that require more abstract thinking. This is essential for moving towards anything resembling AGI.
Is it all about bigger models?
Not necessarily. There's a countertrend focusing on efficiency and smaller models, developing AI that can perform impressively without needing colossal datasets and computational power. Microsoft's Phi models are an example trained on very high-quality data. They achieve strong results with much smaller sizes. This is vital for running AI directly on devices like phones, so-called edge AI.
And what about AI becoming more autonomous?
That's the idea behind agentic AI, moving from AI as a tool that just responds to commands to AI agents that can understand a complex goal, break it down into steps, make a plan, and then independently use tools like software, web browsers, APIs to execute that plan over time without needing constant human oversight.
Like a personal assistant that can actually do
Right.
things.
Exactly. Imagine telling an agent, plan my family vacation to Italy next summer, stay within this budget, find activities everyone will like, and book the flights and hotels. The agent would research options, make decisions, interact with booking websites, and handle the whole process. That shift towards proactive, autonomous agents could be really transformative. Hashtag, outro.
Well, this has been incredibly insightful. It's clear AI isn't some distant sci-fi concept anymore. It's a powerful, evolving field with a rich history, and it's already deeply embedded in our world, often in ways we don't even realize. From simple conveniences to complex scientific tools.
That's right. And this current era, fueled by that convergence of data, algorithms, and computing power, really is unleashing unprecedented capabilities. Generative AI, especially, has given everyone a taste of what's possible when human and machine intelligence start to interact in creative ways. The potential for good is immense in science, medicine, efficiency, tackling global problems. But, as we've discussed, that potential comes hand in hand with really significant challenges: job shifts, bias, privacy, the risk of misuse. These aren't future worries, they are present-day issues we need to grapple with thoughtfully.
So the takeaway for you, listening. The future trajectory of AI isn't set in stone. It's being shaped right now by the decisions we all make, researchers, companies, governments, and individuals. The critical task ahead is to guide this incredibly powerful technology wisely, ensuring it aligns with human values. The question really becomes, how will you engage with this AI-driven future? How can we collectively ensure it leads to a world that's not just more advanced, but also more equitable, prosperous, and sustainable for everyone?